Hello everyone, my name is Andran Alin, the Bazooka Prophet, and I hope you guys are all doing very well. And today, I'm going to be working on a very interesting aspect of the stoichiometry of solution, talking about what we call the molality. Please, it should not be confused with the other term called molarity. This is what we call molality. It is based on the stoichiometry of solution. Now, we're going to be understanding the fact that molality is the number of moles of solute that is being dissolved in 1 kilogram of solvent or 1,000 gram of what now of solvent. Now, without wasting time, the formula on the board is the moles of solute over the mass of solvent in kilogram. It means that the mass of the solvent, when given a mass in gram or in any other unit, it should be converted appropriately to kilogram. And the other shortcut we can also use is the mass of the solute over the molar mass of the solute multiplied by the 1,000 gram over the mass of the solvent in gram. So it means that when the mass of the solvent is given to us in gram, in the conversion processes, this is what we'll use. So let's see a befitting question that will best analyze our question, analyze the subject matter. And the question says, example 1, it says, calculate the molality of sulfuric acid, which is H2SO4, as you will know it. Solution containing, look at that word now, containing 24.4 gram of H2SO4 in 198 gram of water, giving that the molar mass of H2SO4 is 98.09 grams. So what do? You are already aware that molality is equal to the moles of solute. So we can as well say if molality is equal to the number of moles of solute, let's say n over the kilogram of solvent. So we have to first of all get for the number of moles of the solute. So the number of moles of the solute is equal to the mass over the molar mass, and the mass of the solute was given to us to be 24.4 gram, and the molar mass was given to us to be 98.09. That's 98. So it's very simple. So we wouldn't waste any time. Okay, that's equal to 0.249 moles. Now we now for what do we do? Now remember that the 198 gram of the solvent, which is the water, can be converted to kilogram by what now? Divided by 1,000. So when we divide this 198 gram by 1,000, we are having what we call 0.198 kilogram. Please take note, it's as easy as that. Divide this one by 1,000 to get it in kilogram. So we now form the formula. The molality is equal to number of moles of the solute over the kilogram of solvent. So we come here, the moles is 0.249 over, and the kilogram of the solvent, which is 0.198. Together we have it further to be 1.26 molar. Take note, molar, not capital letter M, but small letter m. Now the shortcut for it, so in other way, we can also solve it like this by using the shortcut. Please take note of this. So we can also make use of the shortcut. That one will just give us the answer straight without wasting time. So how do we go about it? Now you're already aware that the mass of a molar mass is 1,000 over mass of the solvent in gram. So what is the mass of the solute there? It was going to be 24.4. The molar mass of the substance was going to be 98.09 multiplied by 1,000 over the mass of the solvent was going to be 1.98. When you do the multiplication and the division sign, you should be having the final answer 2 to be 1.26 molar. So move to another question in addressing the subject matter molality. All right. So we will move to the next question that says, what is the molality of a solution prepared by dissolving by dissolving 20 grams of iodine molecule in 250 grams of tetrachloromethane? Is very easy. So it means that solution from that molality is equal to, from the shortcut, the mass of the solute is 20, and that to get for the molar mass of iodine being the solute, so the molar mass of iodine molecule, if iodine is 127, which is the atom, multiplied by 2 to give me 254 gram per mole. So come here become 254 multiplied by 1000 over 250 gram of the solvent, which is the tetrachloromethane. So when we do the multiplication, the answer becomes 0.315 molar. Final answer. And you realize that calculations involving molality is not difficult. This is the part one. Now in our next video, we'll talk about some questions that might look a little bit difficult, but in the real sense, it is just a simple logic and your understanding. For now, God bless you. Love you guys.